Typical response of control system. So we assume in control system, or we are going to consider here the step response. Step response means at certain time we are going to put at the input step signal, step input. So if step input is applied to the system, how the output going to look like? So the output is going to be the blue color here. I mean this blue color. To understand this output in better way, it's having mainly two main parts. One of them is the starting from the beginning until we reach to the steady state. We call this one a transient. And after that, we are going to check the input. This is the input and this is the output. The difference between them is called the steady state error. Remember, in the closed loop system, we said these two parameters can be controlled. What is the meaning of that? If in the control system we are not happy with the transient, it's long, we can shorten it. Or if it's short, we can elongate it. We can control this parameter. If you look at the steady state error, if I'm not happy with the steady state error, I want it to be bigger or smaller, I can control it with the closed loop system. With open loop system, we cannot deal with this. To understand the response in better way, there is a very good example given in the book. Actually, you can find it. The example is considering the left. If, for example, I am using the left to go from level 1, this is level 1, up to level 4. So my output is level 4. So by pressing on the left, I am assuming that I am going to level 4. That's a step signal. So the left will start operating, going up, 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 up until we reach to level 4. Am I going to go to level 4 exactly? Is the left going to go to level 4 exactly? Or there will be even a few millimeters of difference? That's going to be considered as an error. So I ask for 4, level 4. I am reaching to floor 3.99. For me as a human, I will not notice this problem. But if I want to compare the actual comparison, you will find that there is a steady state error. So the difference between the level 4 which I ask for and the level I reach is considered as the steady state error. Again, I'm telling you here it's steady state error because I ask for 4, I go a few centimeters or millimeters higher than or lower than level 4. Now, the time required until I reach to level 4, this is considered as a transient. The transient time and the steady state error is not values to be fixed for any system. No, every system has its own properties. So for example, in the left, the transient not advisable to be very short and not advisable to be very long. So we want it to be something acceptable by the human. And even the steady state error, very big steady state error is not advisable. Very small steady state error is no problem. It's going to be good. In terms of application of control system, actually there are many applications for control system. Here I am selecting 3 examples like temperature control, automobile cruise control, and liquid level control. Now we will start thinking of how to develop the block diagram of any system. Like here we are considering a tank filled by other tank. So if you look at the system, you will find that we are having, let me call them as upper tank. Here this is upper tank and lower tank. The upper tank is feeding the lower tank through this valve. And the lower tank measuring the quantity of water in it by using the float. It's a very famous system and all of us know it. The idea here is how to convert this system to block diagram, because if you remember, I mentioned it earlier, to be able to control this system, I have to convert it to a mathematical expression, which means I need to put it as a block diagram. How to convert this system to block diagram? That's what we are going to discuss here. We need to understand here, we need to keep in our mind that the parameter which to be controlled is the height. This is the parameter which to be controlled. So that my output is height. The output of this system is height, the water level. And the sensor or the measurement element or measuring element going to be the float. Controller is the valve with the arm, both. Controller is the valve with the arm. So if I know these things, I can somehow build the block diagram. The water coming in, we call it the manipulated variable. It's the variable which going to change the output. Let us look in the next slide on the block diagram or the development of a block diagram. Here, look here, you will find that we have in our mind a preset value. Preset height means I ask the system to give me certain height. There is certain adjustment in the system where I can ask for certain height. And there is a controller. The controller in our case here is the float with the linkage. Notice it's the linkage which is going to be the controller because it's attached to the valve and is going to close the inlet. Now the actuator which is going to control the plant is going to be the source of water plus the valve. So both of these two elements are the controller. Both of these two elements are the controller, which is going to control the water level in the plant. So the plant is the tank in this case. Any opening of the tank outlet is considered as a disturbance. And finally, the output is going to be the output level or the actual height. So that's how I convert. Notice that the controller with the actuator is considered as a controller, both of them. They are the float and the arm with the valve. Then the whole tank is the plant, and the feedback signal is coming from the output here, going to the comparator, where the comparator actually, it's again the float with the arm. Both of them are comparing with the valve. They are comparing and take decision, and the decision will be either to open or not to open the inlet. Another case study here, we are having case study on how to get a physical system to be a block diagram. We have here a position control system. We call this one radio antenna. How to control the radio antenna. Whenever I want to get a block diagram of any system, I need to understand what do I need from this system. So in this case, in our case, we don't want to go to the theory of antenna or theory of whatever. The only thing I need to know here is what is needed from me as a control engineer. I need to direct the antenna to certain position. That means I need certain element to ask for the angle I want. And we need the antenna to rotate. If I want it to rotate, that means I need motor to control it. In the same time, I need something to measure whether I am reaching to the right angle or not. So that's in my mind. Right now, we will convert this system to system with parts. I mean, all the parts of the system are going to be here. So this is the control, where the input, the preset value, where it's going to be sent to amplifier, which going to control the main motor, which control the antenna. So the main motor will operate to rotate the antenna. Then the position of antenna is measured by this kind of sensor. And the signal from the sensor is going to go to the amplifier to do the comparison and whether to stop or not to stop. Now, how to convert this one to block diagram? We can put the system in a form of this block, but this is not suitable for control yet. This is just a kind of a translation of the physical system to a blocks, to physical blocks, where this is the input signal going to go to variable resistor, because we are going to send here electrical signal. The electrical signal is going to go to the differential amplifier, which supply the motor, and the motor will rotate the gear, which means it's going to be somehow attached, connected to the motor. So gear will transfer the signal to gear, which going to the motor, and a gear which connect to a sensor to measure the position. As a control engineer, maybe I don't need all of these detail. I need to put the system as a mathematical expression. That's why I will consider this kind of system, this kind of a block diagram, where the input signal is going to go to the potentiometer, because the input signal is coming from the human, so it's kind of mechanical signal. We use potentiometer to convert it to electrical, so its output will be electrical signal here. That signal will be sent to the comparator. The comparator will send signal to the amplifier. Amplifier will be connected to the motor. Now the amplifier will send electrical signal to the motor. Motor will operate to change the position, the angle. Now the sensor will sense the angle and compare it with the required angle. So this is the actual angle here, and this is the requested angle. Whether they are the same or not, that's to be decided by the system. To understand what is done here, let me just explain what's happening. If I ask for a position of 30 degrees, remember that this is a switch to be controlled by a human. He rotates it. When he rotates it, we are going to get certain voltage here. The voltage is proportional to 30 degrees. Now, 30 degrees, but it's in a form of voltage. That 30 degrees will be sent to the motor, so that the motor will rotate until we reach to that angle. How do I know that I reach to that angle? What will make the motor stop? It's the potentiometer, the sensor. Sensor will sense the signal and compare it with the 30. Until we reach here to 30, so this signal is 30, this signal is 30, so the error will be 0, the motor will stop operation, or the amplifier signal will stop and the motor will stop operation. That means we get to the value we want. So that's how we can convert the physical system to block diagram. Remember that I want to know in a control system, I need to know the input signal mainly, and the controller with the plant, with the feedback. These are the elements which must be in my mind. Whenever you see any system and you need to build the block diagram out of it, you must catch these elements. What is the input, and whether it's electrical or we need to convert it to electrical by potentiometer. What is the output? Do I need to convert it by using a sensor? And what is the controller with the plant? The design process, actually there are a few steps in the design. I will go through them very fast. In step number 1, transform the requirement into physical system. Then number 2, it's draw the block diagram. Notice you can compare whatever written here in these steps with what I have done in the case study. Then number 3, it's the creating the schematic needed to make the approximation, and then develop the mathematical model out of the system. After that, you are going to come out with many subsystems. We can reduce those subsystems, or the block diagram, reduce it to minimum. Then we can analyze the system by sending, let's say finally this is the system. It's having input and output. So we are going to analyze the system by sending certain input and check how the output is going to come. based on that input. The types of input expected in control systems are impulse function, step function, ramp, parabolic, and sinusoidal. We are going to focus here in our course on these signals: step, ramp, and parabolic. These are the signals. This is the impulse. Here, this is impulse, step, ramp, parabolic, and sinusoidal. As I mentioned earlier, we are going to use these signals throughout our course. That's all about week 1. I hope you are clear about it. Thank you.